All right, today we're going to start Chapter 3, Section 3, Analyzing Graphs of Quadratic Functions. Up until now, as I said, we discussed the first two types. We have constant functions, which is a horizontal line through whatever value it goes. And then we talk about linear functions that are lines, whether it's increasing or decreasing. It all depends on a certain part of that function. Just by looking at it, we can tell what type it is. For example, this first one, if there's no x, we know that it's a horizontal line. If there's one x, no exponent, it's an exponent of 1, we know it's a line that only crosses the x-axis at one place. The degree tells us that degree is the highest exponent of the function. It tells us the graph, whether it's linear, if it's quadratic, if it's cubic, it's whatever. So that's what we have to look at, so we know what it's going to be. Now we're going to look at, so this is constant, this is linear. Now we'll look at quadratic functions. To have this shape. Ax squared plus bx plus c. Because of the degree is 2. It tells us the type is quadratic. The degree being 2 also tells us the maximum number of solutions, of real solutions, I should say. Why is it the maximum number of real solutions? Always remember, a solution is the same thing as an x-intercept. Or as we also say, it's a 0. It's when we set the y-axis equal to 0 and find the x values. So that is, we'll be building upon this term later on as well. The reason I say the maximum number is because with quadratic equations, we can have 2 solutions. We can have 1 solution. Or we can have 0 real solutions. Because if your function has an imaginary term, it will look like this. It won't be real. Real means it has an x-intercept. Imaginary means it's somewhere off the x-axis, so we can't do anything with it. Right, we have types of quadratic functions. We have in standard form, and we have in vertex form. Standard form is what we're used to, is f of x equals ax squared plus bx plus c. The vertex form would look like this. F of x equals a x minus h squared plus k. Remember what h and k from when we deal with circles. The reason they call this the vertex form, because the vertex is at the point hk. So just by looking at this equation, we can tell that the vertex is at hk. Only thing this one really tells us is the y-intercept. The y-intercept is at y equals c, or at 0c. So to graph quadratic equations or quadratic functions, we need the following. We need to know the vertex, the direction, the x-intercepts, the y-intercept, and some points. That's what we're going to spend this section discussing. Yes, and we can find the vertex from this one with some algebra. In general, any type of equation you have, I don't care how big or how small it is, once you put the x's in decreasing order, this is x squared, x to the 1, x to the 0, it's gone. This is called the leading term. It's what defines, it tells us everything we need to know about the graph, pretty much, except for the y-intercept. It tells us because in there we have the degree, and the degree tells us the shape of the graph. Whether it's quadratic, whether it's linear, whether it's constant, if it's cubic, whatever. Then A is called the leading coefficient. It tells us the size and direction of the graph. What does that mean? Well, if these are regular quadratic equations, the graphs, x squared. If A is bigger than 1, then we know it's going to be skinny. If A is between 0 and 1, I should say absolute value, then it's going to be wide. So that tells us the shape and the size. The direction. This is if A is positive This is if A is negative, it goes down. All right, let's put a lot of this stuff together. So how does the leading coefficient, leading term help us? Well, maximum versus minimum. There's the highest versus the lowest point. Of the function f of x equals x squared. For right now, we're going to ignore everything else. We're going to look at the leading term. These are for x squares. If A is positive, in other words, it opens up, we have a minimum. Minimum is the lowest point. If A is negative, we have a maximum or a high point. If A is negative, it looks like this. So we have a maximum, a high point. And the vertex is the highest, lowest point of the graph. So first, let's look at standard form. Of quadratic equation looks like this. Graph. We'll first need a vertex. We need the degree. We need the y-intercept. We need the x-intercept or x-intercepts. All right. So if we're in this form, in standard form, the vertex, actually we've done this already. Remember the quadratic formula? The vertex is already built into this. If the discriminant, that part in here, if it equals 0, that equals 0, then what we have left is negative b over 2a. And remember, our graph of the x squared function looks like this. So the vertex is a point. It needs an x and a y component. The x component is made up of negative b over 2a. That's that one. That tells us the x value. Once we find the x value, plug that back into our function for the y value. Now, here's another thing. Because of vertex, if we drew a line through the middle of it, it's symmetric. What happens on this side happens on this side. For example, for x squared, if this was x squared, if x is 1, 1 squared is 1. If x is negative 1, it's 1. If x is 2, it's 4. If x is negative 2, it's 4. So it's mirrored image on both sides. We call that the axis of symmetry. The axis of symmetry is simply the x value of the vertex. That's the axis of symmetry. Because think about it, the vertex go horizontally for the x value, go vertically for the y value. The degree, that's the largest number. That's usually an n. For larger equations, we'll talk about next chapter. The y-intercept is a constant. So y equals c at the point xc. The x-intercepts, we did that last chapter, or earlier this chapter. We learned how to factor, we learned how to complete the square, how to use the quadratic formula. So that's how we find the x-intercepts. Okay, so let's look at some examples here. F of x equals x squared plus 10x plus 23. What this question is looking for is find the vertex, find the axis of symmetry, and the max min value. All right, so our vertex. Remember, we had x is negative b over 2a. So we're in standard form, so we can label a is 1 in this case, b is 10, and c is 23. So plug that in there, we'll get negative 10, b is 10, 2 times 1, so it's negative 10 over 2, makes it negative 5. So there's the axis of symmetry. The axis of symmetry is x equals negative 5. So the vertex has a x value of negative 5. Now the y value, I just take that value and plug it back into the equation. So f of negative 5 equals negative 5 squared, 10 times negative 5, 23. -5 times -5 is positive 25. Positive times negative is negative. 10 times 5 is 50. Plus 23. 25 plus 23 is 48. 48 is positive, 50 is negative, so the answer is negative. 50 minus 48 is 2. So our vertex is at -5, -2. Now our axis symmetry is the x value, the max and min. A value is 1. It's greater than 0. So it opens up. If it opens up, we have a low number. So it is a min. So we have a min at the value of y equals -2. That's all there is to it. That's a good example too. We want to find the same things for this function. X squared over 2 minus 4x plus 8. So we're looking for the vertex, the axis of symmetry, and the max min. And then we'll graph both of these. So here we've got label A, B, C. A is whatever is in front of the x squared, which is 1/2. B is -4, and C is 8. So the vertex is -b over 2a. Negative of -4 over 2 times 1/2. Negative and negative cancel. That gives us 4. 2 over 1 times 1 over 2, the 2's cancel, so we just have 1. So the x component, the axis of symmetry, is 4. The axis of symmetry is x equals 4. Now we got to take this value and plug it back in the original. So it's 4 squared over 2 minus 4 times 4 plus 8. Let's see this one. 4 squared is 16 over 2 minus 4 times 4 is 16 plus 8. 16 over 2 is 8 minus 16 plus 8. 8 plus 8 is 16. So it's at 0. So the vertex is at 0. So now, since A is 1/2 and that's greater than 0, it opens up. So we have a min. So we have a min at the y value. It's 0. Let's look at those two functions and graph them. So in example 1, our function was x squared plus 10x plus 23. And this one was x squared over 2 minus 4x plus 8. So in this first one, we found the vertex at -5, -2. The axis of symmetry was at x equals -5. And we had a min at the y value of -2. And we knew that a is equal to 1, which is greater than 0, so it opens up. So let's first find the vertex. 1, 2, 3, 4, 5. Go to -5, and then go down 2. And that is where we have our vertex. Now, our axis of symmetry is this vertical line right here. Because whatever we put on one side, we can't do the same thing on the other side. So we have to find some points. So we have the vertex. We can find the y-intercepts. Remember, x equals, since we can't factor this one, we know we can't factor because what times what is 23? When you add them, you get 10. Nothing. So we got to use the quadratic formula. A was 1. We have 2 times 1. B is 10, so it's -10 plus or minus 10 squared. 4 times 1 times 23. -10. 10 squared is 100. 4 times 1 is 4. 4 times 23 is 92 over 2. -10. 100 minus 92 is 8. 8 is made up of 2 times 2 times 2. It's a square root, so we take out one of the 2's. We have one of them left in there. On top, 10 and 2, they both have a 2 in common, so we can take that out. So 2 goes into -10, -5 times. And take out the 2, so it's radical 2. Those cancel, so these are my x-intercepts. -5 plus or minus radical 2. Radical 2 is just a little bit bigger than 1, because the square root of 1 would be 1. the square root of 4 would be 2. So this one, let's say it's 1.2. Because it's pretty close to 1.0. So 1.2, so we have 1 there. So I go over 1 to the right, 0.2, and then I go 1 to the left, 0.2. They're symmetric. All right, so let's pick a point. -3, so it's 2 spaces to the right and 2 spaces to the left. We put -3, that's this, it'll be up here somewhere, and we have -7. That's this one. So I gotta find a couple of points. We know it goes through the vertex, it goes through the x-intercept there. We just have to find a couple of more points. We also know that it crosses at 23. So we can use that as a point. From -5 to 0, it's 5 spaces, and then up 23. So we can go from -5 over 5 spaces, all the way to -10, and then up 23 spaces. So we know the graph will look something like this. It opens up, and we know those points. For example 2, we knew our vertex was at 4, 0. Axis of symmetry is x equals 4. The y-intercept, our low point, the minimum point is 0. Oops, sorry. We also know our y-intercept is 8. So we know that 1, 2, 3, 4. We have our vertex at 4, 0. We know that 3, 4, 5, 6, 7, 8. We know that at 8, we have a y-intercept. So that's from this point, it's 4 to the left, 8 up. So if we go 4 to the right, 8 up, we have another point. So there we have our graph. We don't have to solve for this one because since it lands on the x-axis, that's the only x-intercept we have. We're gonna have to do all the other work. Let's do another one before we change formats. Example 3. F of x equals -2x squared plus 10x minus 23 over 2. We're asked to find the vertex, the axis of symmetry, and max or min. So here we have A is equal to -2, B is equal to 10, C is -23 over 2. of the vertex. X value of the vertex is at negative b over 2a. So we have negative 10, that's b, over 2 times a. A is negative 2. So we have negative 10 over negative 4. The negatives cancel. We have 10 over 4. They both have a 2 in common, so we cancel out the 2's. So our x value is 5 over 2. It's at 5 over 2. So the axis of symmetry is at our point x equals 5 over 2. Now we've got to find the y value. So we put 5 over 2 in place of our function, negative 2, 5 over 2 squared, plus 10, 5 over 2, minus 23 over 2. So we have a negative 2, 5 over 2 squared. So the square both top and bottom, we get 25 over 4. Reason, because when I simplify this one, 2 goes in 2 once, 2 goes into 4 twice. I got negative 1 times 25 over 2 plus 10 times 5 over 2 minus 23 over 2. Notice they all have over 2, so I could just leave those alone. So it's negative 25 over 2. 10 times 5 is 50 over 2 minus 23 over 2. Negative 25, negative 23 is negative 48 plus 50. So 50 minus 48 is 2 over 2, which is 1. So our y value of the vertex is at 1. Since a is negative 2, a equals negative 2, and that's less than 0, we know our graph will open down. So we're going to have a maximum. Our maximum is at 1, the y value. So the graph of this one, since it opens down, the vertex is at 5 over 2. 5 over 2 is the same thing as 2 and 1/2. So 2 and 1/2 and 1. There's our vertex. Remember, the axis of symmetry is 5 over 2. So it's symmetric. Yeah, what we look at over here is our y-intercept is going to be at 23 over 2, which makes it 11.5. So 23 over 2 is 11.5. So we go all the way down here to negative 11.5. There's 11 and there's 12. So we go over 2.5, down 11.5. If we go 1 over 2 this way and down 11.5, we have our graph. Since the absolute value of 2 is 2, it's going to be a little bit more narrow than the original function. The only thing we have to do is figure out what the y-intercept or x-intercepts are to make it look nice. So to find the x-intercepts, we use the quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. And I have everything listed up there, so I have, this is why I listed everything up here. So I have negative b, which is 10, negative 10, plus or minus 10 squared minus 4 times a is negative 2, times c, which is negative 23 over 2, over 2 times negative 2. So we have negative 10 plus or minus 10 squared is 100. Negative, negative, negative makes it a negative. So then the 2 cancels with the 2. So we have 4 times 1 times 23. So 4 times 23 is 92 over negative 4. 2 times negative 2. Negative 10 plus or minus square root 100 minus 92 is negative 8 over negative 4. Negative 10 plus or minus square root of 8. 8 is made up of 2 times 2 times 2. So we get 2 radical 2 over negative 4. Okay, first, let's look at the signs. What the signs tell us is, okay, what's going to happen here is because the bottom's negative, I got to change all the signs on top. Because this one cancels with this one. So it changes the positive to negative, negative, positive. So the only thing that changes is that first sign, because the opposites will stay the same. So now it's positive 10 plus or minus 2 radical 2 over 4. On top, we can factor out a 2. We take out 10, there's 5 of those. Take out 2, so we have radical 2 over 4. The 2 and the 4 cancel. So our x-intercepts are at 5 plus or minus radical 2 over 2. And if you look at it, it's pretty close to what our graph says. Say 5 plus or minus 1.2 over 2. We have 5 plus 1 over 2. 5 plus 1.2 over 2 makes it 6.2 over 2. 2 goes into 6 3 times, 2 goes into 2 once. So at 3.1, yeah, it's pretty close. Remember, this is 1, 2, 3, 4, 5. Then we have on the bottom, we have 5 minus 1.2 over 2. 5 minus 1 is 4. Minus 0.2, so it's 3.8 divided by 2. 2 goes into 3 once with 1 left over. 2 goes into 1.8.9 times. So it's just above 3 and just below 2, which is exactly what our graph looks like. Here's an example of, well, I'll give you an example also of the other form, the vertex form. Let's see. Let's look at this. A vertex form. F of x equals negative 2 x minus 1 squared plus 3. Right. It's vertex form because it has this basic form. A x minus h squared plus k. We do the same things. Vertex, axis of symmetry, max or min, and then the graph. For us to graph it, we need x-intercepts, the y-intercepts. Those are some points we need. Okay, the vertex is at the point hk. X minus h, so h is 1, 3. Axis of symmetry is x equals 1. A is negative 2, which is less than 0, so it opens down. That means we have a maximum at 3. So the highest point of our entire graph will happen at y equals 3. So we have a vertex at 1, 3. Three. So at 1, 3. And x symmetry is there. The new origin's up there. It opens down. So let's look at x-intercepts. The way you find the x-intercept, remember, set y equal to 0, solve for x. So we set the equation equal to 0. And solve for x. Subtract 3 first from both sides. Change the signs and divide by 2. So we have 3 over 2 equals x minus 1 squared. we're going to try and solve for x. So square root both sides. Because I square rooted something as squared, I got to put a plus or minus in front of that. So we have x minus 1 equals plus or minus square root of 3 over 2. And then we add 1 to both sides. So x equals 1 plus or minus square root of 3 over square root of 2. Okay, now remember, you cannot have square roots on the bottom, so we multiply top and bottom by square root of 2, and that gives us 1 plus square root of 6 over 2. One plus or minus. So we get square root of 6. Square root of 4 is 2. Square root of 9 is 3. So this number here is bigger than 2. All right, so we're looking at there, since it's bigger than 2, 2 divided by 2 is 1. So we're looking at 1 plus or minus 1 point, let's say 1.4. 1.2, yeah, something like that. If you have a calculator, you could do it much better. So those are my x-intercepts. So 1 plus or minus 1.4, 1 plus 1.4, and 1 minus 1.4. So it's minus 1 and 0.4. So those are my x-intercepts. My y-intercept is f of x equals negative 2, x minus 1 squared plus 3. So the y-intercept is when you set x equals 0. And solve for y. So f of 0 equals negative 2, 0 minus 1 squared plus 3. Negative 2, 0 minus 1 is minus 1 squared. Negative 1 squared is 1. Negative 2 times 1 is negative 2. Plus 3 is positive 1. So the y-intercept is at positive 1. So since we know that point, the vertex is at 1, 3. So if we go 1 to the left and 2 down, we go 1 to the right and 2 down and get another point. So our graph looks like this, roughly. All right, let's look at some applications here. So the example 5. The landscaper has enough stone to enclose a rectangular koi pond next to an existing garden. A garden wall of an Englishman's house with 24 feet of stone. If the garden wall forms one side of the rectangle, what is the maximum area of the landscaper that the landscaper can enclose? So we're looking at maximum area. So we're looking at area. What dimensions of the koi ponds will yield this area? So here's our picture. Here's a wall. And we'll make a koi pond from it. And we're looking for the maximum area. The formula for an area of a rectangle is base times width. Length times height, so x times y. Well, I'm going to use x and y. Here's x, that's the horizontal, and here's y. So there's y also. Why is that important? Because I only have enough stone, and what that gives me is the perimeter. So so we know the area formula is going to be x times y, but we know the perimeter is we have y plus x, y plus x plus y, which is x plus 2y. So these are the formulas that we need. But what do we know? What do we know about the perimeter? How many stones, how many feet of stones do we have? We have 24 feet of stone. Because we have 24 feet. That's how much that can be in there. All right, so now let's see how this relates to what we're trying to get to. We have an equation with two variables. We have another one with two variables. We can only have one equation with one variable. So what we have to do first is let's solve for a variable here. Let's solve for x. So if we subtract 2y from both sides, we get x equals 24 minus 2y. That's what x means. So x is informs y. So our area formula, anywhere I see an x, I put 24 minus 2y times y. Okay, let's look at this one. So if we distribute this, we get 24y minus 2y squared. So it's negative 2y squared plus 24y. So we know our graph is going to look like it's a downward graph because a is negative 2. So it's a downward graph. So if we look at the graph, we know it's a downward graph. Do we know the x-intercepts? Yeah, we know them from here. So if we set the area equals 0, that means what we have to do here is take both of these equal to 0. So we have 24 minus 2y equals 0. And we also have y is equal to 0. So at y equals 0, when x is 0, that's one of our points right there. And then we have move the 2y over. 2y equals 24, so y equals 12. And there's our, so we know our graph will look like this, where this is the dimension, or the x, and this is the area. We're looking for the highest area. Because this is a quadratic equation, it's symmetric. In other words, it's equal both sides. This happens when x equals 6. That's in the middle of those two. So when x equals 6, we get the maximum area. So we have the area, we'll use this equation, 24 minus 2y times y. In this case, it's x as our input. So whenever y is equal to 6, that'll give us our largest area. Ooh, x is our width. X is 6. If now we have to solve, since our equation's in y, we have to solve for y. Since our equation is with respect to y, and we know x equals 24 minus 2y, we need to find y to plug it back into the equation. So when the question says when x is equal to 6, when the horizontal, when the length, the width of the whole thing, when the width is 6 feet, what's the depth going to be? So when x equals 6, we got 24 minus 2y. Subtract 24 from both sides. So it's negative 18 equals negative 2y. Change the signs, divide by 2. So y equals 9. So when x equals 6, y equals 9. So our dimensions of our pond will be 6 by 9. 6 feet wide, 9 feet deep. So the area is going to give us 24, 24 minus 2y. So 24 minus 2 times 9 times 9. So 24 minus 18 times 9. 24 minus 18 is 6 times 9. So that's our area. And the other examples are going to do the same way. Just put them in an equation and solve. And they'll give you the equations. All right, that's it for that section.